Good morning, everybody. This is Andrew Krinsky with Cambium Networks. Thank you all for joining us. Today we'll be going over GPS synchronization and network scalability with Dave Geithner. If anyone has any questions or concerns, there is a comment box on the right side. Just open that up and type any questions you might have, and we'll go along and answer those as the PowerPoint goes on. So from that, Dave, it's all on you. Go right ahead.
Great. Thanks a lot. I presume you can hear me okay?
Yep.
Okay, great. All right, so we can get started here. So today, as the slide certainly depicts here, we're going to talk about GPS synchronization and network scalability. I'm going to do a slightly different pitch on this. We do a lot of conversations, a lot of videos, a lot of teaching in our classes and such on synchronization and the importance of it and things of that nature. And a lot of the speak around it is, well, you can scale great, you can frequency reuse great, helps with interference, things of that nature. And those are all true, of course, but they don't necessarily really explain exactly what's happening with GPS synchronization or synchronization just in general. And so for the next few slides here, I'm going to speak maybe a little bit more in detail of exactly kind of what's happening under the hood, a little bit, not too down in the dirt detailed, but just a little bit more specifically about the synchronization. First, though, and you can flip to the next slide if you would. Excuse me. But first, just to kind of put it out there, to get wireless solutions to work well together in small or large deployments, for that matter, it really takes several attributes, features, functions to be addressed to get that to work. Things like having good transmit power control within your radio solutions, having optimal antenna specifications, front to back ratios that are optimal to allow you to do a lot of frequency reuse and interference rejection, adjustable duty cycles, et cetera, et cetera, et cetera. Today we're going to focus, as I mentioned, predominantly just on the synchronization, and that's probably the most important of all those different attributes that we kind of talked about to help you with scaling, help you with network growth, help you with interference mitigation. But it's more than just that one piece, and I just want to make sure we kind of get it out there to make this all work together. And that's the total package. That's the total solution that Cambium's able to bring to you with our point-to-point and point-to-multipoint type solutions. So, and I say point-to-point, a lot of people, when we think synchronization, that means immediately, well, that's a point-to-multipoint thing that helps you deploy a lot more point-to-multipoint products easily. Yes, however, synchronization is used just as much, well, maybe not just as much, but can be used quite a bit, and it often is used quite a bit in point-to-point systems where you're doing multiple point-to-point systems on a central location and you need to synchronize those to be able to get all the same benefits that you get when you're doing a point-to-multipoint system of synchronization. All right, so enough of an intro. This is what we're going to be trying to answer here with this webinar. That is predominantly number one, what is synchronization, what it's really used for, how is sync applied to my network, and we'll go through a few examples of that so you kind of get an idea in your head. And then what do I even gain by using it? And we'll just touch on a few of the high-level ones, and we'll speak a little bit deeper, just slightly. All right, so what is synchronization used for? Wow, your timing is perfect. Synchronization in the context of wireless networks is really controlling the transmit and receive time for TDD access points in a given area, ultimately resulting in the elimination of self-interference. That's really what we're driving for. Interference is a killer of throughput, a killer of efficiency within wireless radio solutions. And meaning if I have a radio that's spec'd for 100 megabits throughput, just to keep things simple, so I should be able to get 100 megabits of capacity between point A and point B over a wireless link. Great. However, if I start throwing interference in that link, that's going to erode the efficiency of that link, and instead of it being a 100 megabit link, which it's fully capable of doing, it now becomes a 60 megabit link or a 50 megabit link, solely because I have other links that are into my control that are interfering with it because I'm not able to time sync these transmit and receive times for the radios, and we'll talk a little bit more about that. So I said TDD access points. What is TDD? This is a nice explanation. But what does it mean? We first need to understand what TDD is, time division duplex, and we'll speak to that with a couple of transition slides here. So first, understanding duplex here. We have two radios that talk to each other, and duplex high level is basically meaning that it's transmitting in both directions. So if you click through the slide a little bit here, you see we have a downlink direction of information traffic flow, and we have an uplink direction of traffic flow. So this is a duplex radio. It's able to talk in both directions. But how we talk in those both directions is defined by another type of term, and that is the two most prominent ones. And if you click through a little bit more, I think there's here. The two most predominant ones are frequency division duplex, FDD, and time division duplex, TDD. Okay, so now let's understand a little bit more about those and how do they work? What's the difference between them? So we'll start with FDD, frequency division duplex. So this is where you have one end of a link you have a transmitter and receiver, other end of the link you have a transmitter and receiver, and in order to transmit information from one end to the other end, you're able to transmit. So let's click through if you would. The F1 frequency number 1 is transmitting to the receiver number 1, and the transmitter on the bottom part is transmitting to the receiver on a separate frequency. And they're able to do this simultaneously without any pause or change in timing or things of that nature. They have what's called a forward or downlink and a reverse or uplink type of path. And often when you're doing this, because there's two separate frequencies, you need to have a guard band, what's called a guard band. It's basically open space between the two so that they don't self-interfere. There are some benefits of having frequency duplex or frequency division duplex type radios. That's predominantly what's known about them is that they're ultra low latency because there's no pausing. It's constantly transmitting in one direction, receiving in the other direction simultaneously. So very low microsecond type of latency with this type of solution. But the real con with using an FDD type of solution is that it's not efficient with spectrum usage. And as you can see here, I have to have a dedicated frequency for the transmitter receiver in one direction path, and then a separate frequency for the transmitter and receiver in another path. And then I also have to have additional spectrum chewed up for this guard band that we talked about. So it has a good role for very ultra-low latency solutions. You find this often in your licensed microwave backhaul solutions, such as like our PTP-820 or 800 or 810. But because in that area you go out, you license your frequencies, and you are assigned those frequencies, and there's a very, very large chunk of spectrum assigned to licensed microwave, from 6 gig all the way up to 36 gig and beyond. All right, so now let's move to TDD. So TDD is time division duplex, and what this is using the same frequency, you can transmit information in one direction, and you can click through this one a little bit as well. So on the top you'll see the frequency number 1 transmitter sending information over to the receiver, and then there's a pause, there's a stop, and then the site on the right then transmits on the same frequency as what was being used before back over to the other receiver. So you have this kind of cycle. One side transmits to the other for a period of time, and then the other side transmits back for a period of time. There'd be a slight little guard time required for a pause between those transitions. So TDD solutions incur a bit higher latency than FDD, and you can kind of see that probably visually of why that would be, because I have to transmit one way, stop, and then transmit another way. But this is super fast, really, at the end of the day. So we're talking about very low millisecond type of solutions, which is perfectly, extremely fine for sensitive applications like VoIP or things like that. But probably the key benefit with TDD is that it's very, very efficient with spectrum usage. And when you're dealing with spectrum areas like 2.4 or 5 gig unlicensed type spectrum, where you don't always have a whole lot of clean areas to deploy your technology, deploy your wireless link. Being very efficient with spectrum usage is critical, is key, is an asset that you need to have as part of the wireless technology solutions that you're looking to deploy. All right, so now I understand a little bit about time division duplex. So, and I know that it's a solution that's basically over some period of time is transmitting in one direction and then stopping and transmitting in the same direction or in the opposite direction using the exact same frequency. So Cambium Modules uses TDD time division duplexing to alternate transmissions between uplink and downlink, as we kind of just went through here. Just for your knowledge, on the opposite direction, when we're talking in a point to multi-point scenario where an access point is talking down to all the subscribers, that's pretty easily accomplished. But when you have multiple subscribers trying to talk back up to a single access point, Cambium utilizes a time division multiple access type protocol in order to resolve any contentions for those subscribers to come back up. And that's just kind of a little bit of anecdotal information. If one access point was to transmit while another is receiving, the possibility, in fact, not necessarily the possibility, but the high probability of interference or desensing, what's called desensing of the receiver, exists. And that leads to a degradation, some oftentimes very significant, in your overall throughput performance. So APs, access points, must be synchronized to prevent interference and desensing. You can click through here. I think we have a couple of animations that help bring this to life. So here is a initial kind of animation that kind of shows up to 6 access points that are all co-located on a single tower, single structure, and they're transmitting at various different times because they're not synchronized. And these green and yellow, or orange, if I guess you can call it orange or gold, blocks represent the different TDD duty cycles or TDD instances. So one block is for what we would call the downlink of a particular access point, and the other blocks, say the orange, are the uplink. And you can see, if they're staggered like this, that sometimes the orange are overlapping the green of a nearby or neighboring access point. And that's where that unsynchronized self-interference comes to light and crushes the overall capacity of a particular site's worth of access point. So what do we do to alleviate that, to get rid of that, to make this work efficiently and effectively? Obviously, per our conversation here, is adding in synchronization to it, and we'll talk about those different sources. But for right now, we're gonna add synchronization. So when we replay that same scenario that we just played out, except now we have synchronized. We have what's called a CMM. You can see on that little tower structure in the center, something called a CMM, cluster management module. In this particular instance, in Cambium solution, that's one of the solutions that you can use to provide common timing solution to all those access points. So now when they start their duty cycle, when they start that TDD cycle of transmitting in one direction and then returning, transmitting in the opposite direction, they can all be perfectly synchronized so that none of those access points are transmitting when another neighboring access point is receiving, and thereby blasting into that access point's receiver and desensitizing it and causing interference and spiraling into basically losing the efficiency of that whole sector. All right, next slide. So this is to kind of show, you know, it only takes one. It only takes one access point or co-located radio that you have operating on a single asset structure to be out of sync to totally destroy or totally interfere with all the other access points. So just because you have, don't necessarily get in your mind that, hey, you know what, I'm using synchronization like 90% of the radios I have on the tower, and I only have one that's not synchronized. It's a different solution for whatever reason I'm using it, and it's not synchronized, so it can't be doing that much harm. It can, and this little visualization hopefully kind of shows that. If you're transmitting on the time when all the other radios are receiving, and these are all co-located very close to each other, you can desensitize all the receivers at that time by that just one transmitter, that one rogue transmitter, and again cause a lot of interference, self-interference, and destruction of the capacity. Next slide. So again, so how we do this? Let's see here. There basically are many different ways to achieve synchronization in a network. We employ most often GPS synchronization, global positioning satellites, not to derive any actual positioning information from it, but for the timing of it. There's a very precise timing pulse that also comes with being able to receive GPS. And that very precise timing pulse is what we are able to use not only at a single site to synchronize all the access points that might be deployed at a single site co-located on a single tower or single structure, but in a whole neighboring of sites or a whole federation of sites, sometimes the term used. And so here you can see that not only is a single site, all the transmit and receive duty cycles synchronized, but across your network you're able to ensure that that is happening, and so that you're not interfering with other towers that are in your network that are nearby can hear each other. So that's really kind of the key reason why we utilize GPS. GPS is heard throughout the world and is a solution that is proven that we can perform this type of synchronization well with our radio solutions utilizing GPS. So how is sync applied to my networks? Very simple, very kind of quick slide, but basically we talked about GPS. So a number of these radios that you see here, let's take the Canopy 450 picture up top, top right-hand corner. You see multiple access points deployed on a structure there, and they're all being timed by a GPS that you see directly below it, or a device similar to that, as well as the access point, which is the radio piggybacked on the back of the antenna in that upper picture. It has also an onboard GPS built within the radio that can be utilized as well if needed. Oftentimes we utilize that more of kind of a backup GPS, because depending on the actual way that you have that radio mounted on a tower or things that might be above that tower, it may be obstructed from seeing GPS very well. So we often use that one as a fallback. Excuse me. Sorry. So more often we'll use a dedicated GPS that is mounted somewhere where it's got clear visibility of the sky, that provides the sync pulse up to all those various different radios via a sync cable, or it can also be embedded right on the power over Ethernet and data cable, so that you only need a single cable going up to the tower, up to these radios, and that is providing that synchronization all throughout the network. Down on the right-hand corner, you'll see a little bit more of a visual of what we call that cluster management module. If you remember in the slides a little bit further back, there was something called a CMM on that tower that was providing that sync in that animated slide. This is a little bit more of a visual of the actual hardware of what's in that CMM. There's a GPS that's attached. You can't really see it too well, but it's attached to the top. It feeds into that, and then that basically distributes the very precise timing signal up to the radios, and that's what's used to synchronize their duty cycles, synchronize their launch times. Right directly next to that, you'll see a rack-mounted version of the same exact product. Same thing as what you're seeing in the box, except it's now 19-inch rack mountable for indoor implementations that sometimes customers want to do. And then over to the far left is an ePMP solution. You'll see the ePMP access points on the very far right, and they have GPS receivers built into the radios as well. Those, however, are mounted right on the top of the antennas, so they more often than not are perfectly fine as is using those integrated GPS solutions. All right, next slide if you would.
Fantastic, Dave. We have a quick question here from a network operator. He's asking, in using 5 gig and 365 450 access points with universal GPS modules, but the selection of the GPS is usually the internal 450 GPS built into the 450 rather than external. Is this normal, or is there any preference that you would recommend?
We definitely try to recommend, and it depends on your particular deployment. Generically speaking, we recommend that you utilize the internal GPS of those radio receivers or those radio access points as a secondary GPS source because of some of the reasons that I said. Oftentimes, the radios, because of the way they're being mounted with the antennas right directly against them, that they can be blocked. Those particular GPS receivers internal to the radio itself, the access point itself, do not have the option for an external antenna patch like our EPMP solutions do. They have the option to screw on an external GPS antenna and place it slightly away from the radio or away from the antenna so you're not blocked. In other instances, perhaps like the one you see for Canopy 450, where it's the tallest asset on that tower structure, it's really not necessarily being too blocked with the sky or the horizon. It might work okay for you. But if you want general guidance from Cambium, from the manufacturer, we tend to encourage the built-in GPS as being a secondary. And you can set it up within some configuration parameters available in the radio of what you want to be your primary timing source, what you want to be your secondary timing source. Do you want to allow free run for a moment in time? If you have a temporary loss of GPS, allow it to free run for just a little bit of time and then eventually determine whether you want it to shut off or if you want it to keep running. There's various different flexible options for how the access point can run based on what GPS you've selected and is that GPS available, meaning an external GPS or an internal GPS or something coming from the sync port or just using internal timing. Hopefully that answered the question.
Thank you, Dave. And then on top of that, we have a network operator asking, how do you set the external to be the primary?
So there, in the access point, I believe, well, I'm quite certain that there's various different selectable options for it, and I don't have them memorized off the top of my head. And I apologize, I'm remote at the moment, so I'm not in my office where I can quickly just log into one and read it off to you. But I believe that there is a setting that you can select which solution you want to utilize, whether it's timing coming from the PoE, timing coming from the external sync port, timing coming from the built-in GPS, as far as operating the unit. So it's basically within the radio configuration. I believe it's under general. There's different tabs on the access point, and under the first general configuration tab is the selection of how you want the GPS synchronization to work and where you want it to derive that signal. In addition to that, just to mention that in the same landing page, there's a dedicated tab to showing the status of the GPS receiver, how many satellites it's seeing, what the radio has chosen to use as its primary sync source, what are the statuses of the secondary and tertiary selections for GPS as well. So it gives you all that nice little dashboard view of not only where are you currently deriving your GPS from, but how are the status of your backup GPS sources if you choose to use those backups or configure those backup sources.
Thanks, Dave. And then we have a great question here regarding co-location and other vendors' radios. Can GPS synchronization help with external interference with those radios?
So that's a big depends question. As I mentioned at the beginning of the webinar, at the end of the day, there's really several factors that goes into allowing a radio network solution to work well, efficiently, be able to reuse frequencies, not self-interfere, things like that. GPS synchronization is just one part of that. The other examples I gave that build into this solution are having automatic transmit power control that works well, having good specifications on your antennas, your access point antennas that have very good front-to-back ratios, and there's big, strong reasons for that being needed. Duty cycles, having the ability to set your duty cycles, things like that. So it's hard to say, can you co-locate with certain radios and be synchronized if you just use GPS synchronization? That would be hard because you need not only just GPS synchronization, which is a feat in itself to make sure that it works right, because a lot of other vendors have tried and a lot of other vendors have failed to get GPS synchronization to work right, but you also need all those other factors too. So we would probably need to have some additional details on exactly what they're trying to do. I think we're going to get to a slide where it talks about the forum and places where you can go post some of your questions, and then we can get detailed answers and specific information more about the other radios that you're talking about, and perhaps address it that way. All right, so I think we've talked through a lot of this already. The CMM3, there's another version called CMM4, and a UGPS, Universal GPS, contains a GPS receiver, tracks 8 or more satellites, and provides precise clocking to synchronize Cambium access points. You can read kind of through the rest of this on your own, but in general, I think we're aware now of what these type of devices are that actually connect to our access points, receive GPS information, derive a precise timing clock, and feed that timing clock to all the access points to be able to allow those access points to universally synchronize their TDD cycles, and thereby being a synchronized, operating in a synchronized, harmonious synchronized mode. All right, next slide. All right, so then to the final parts here. What do I gain by using it? Again, we've talked through a lot of these, but basically having the ability to employ synchronization techniques in the wireless networks, or in wireless networks, means very efficient use of valuable spectrum assets. And I can't emphasize that enough. When you're dealing with unlicensed space, sometimes if you're really isolated and way out in isolated areas, mountains, up in the Arctics, out in rural whatever country that you're in, maybe that's not so much of an issue for you. When you're dealing in urban environments and noisy environments, ports, challenging environments where you don't have a lot of spectrum space, then having a solution that is able to be very efficient with those spectrum assets is like gold. Easing the RF planning tasks for network growth. So also with this ability, and we didn't really use this term so much, but also with the ability to have a synchronized network, it enables the ability to reuse frequencies on the same tower, because I'm not going to be self-interfering with these other radios if I have all my transmit and receive duty cycles, TDD cycles, synchronized. So I can now not only efficiently utilize that spectrum asset, I can efficiently use it by reusing the same exact frequency, that F1, as we showed on one of the animated slides earlier. I can reuse that on the same tower asset, and because I'm synchronized, because I'm using a very precise timing solution to be able to synchronize all of my access points, I can now reuse. Again, gets back to that very first thing. If I'm able to efficiently use the spectrum that's available to me, not only use, but reuse on the same exact tower, that's gold. That's gold, and that makes the RF planning tasks, if I'm growing my network further out, that much more valuable. And of course, being a synchronized solution and doing it right provides operators with consistent and predictable wireless broadband service performance to their end customers. And that's definitely something that's in our core values for the products that we produce and put out there for the last 10, 12 years. All right, next slide. So we talked a little bit about that frequency reuse. So this is just giving you a little bit of a visual of how synchronization allows that frequency reuse. So if we imagine that each one of these little cells or sectors letter designation is a separate frequency. So on the very top one I have frequency A, frequency B, frequency C. With synchronization I can use that exact same pattern on the backside of that same tower structure. Frequency A, frequency B, frequency C. If you didn't have synchronization, this would fall flat. This would fall flat as far as the interference that the two access points that are using the same frequencies on the exact same tower structure, when they're transmitting unsynchronized, you will have significant, severe impact to the overall throughput that these radios are able to produce. Add in that synchronization, and you're back to the spec sheet type of performance and the efficiencies that the radios are capable of. And there's different configurations. There's 4-sector solutions. There's 6-sector solutions. But this is what we're talking about when we're saying synchronization at the end has a result of being able to help ease the growth, the network growth, and be very efficient with that spectrum usage. All right. So next slide. Again, this is just kind of building it out to so not only are you able to do it with one site, but then when you build a federation of sites and you're utilizing that synchronized type of technology on all the different sites, it makes things so much more easier. This is just a general example, not necessarily saying this is exactly how you would deploy it, but you get the idea, you get the picture, you get the feel of how this thing can grow quite easily utilizing these techniques. All right, next slide. All right, I think this is where I turn it over to you to kind of speak through the social media aspects.
Thank you, Dave. So for everyone that attended, thank you so much. You can always follow up to the latest news and information on our social media pages from Facebook, LinkedIn, Twitter, and so forth. And don't forget, we have a great tool utilizing the community where you guys have a voice, and we obviously focused on that very strongly. You can put any ideas that customers have been utilizing and we've been listening and implementing into our radios. Any knowledge that you would like to spill, anything that you've configured and done in the past, as well as your stories. What have you seen out there? What do you like? What do you don't like? All that information is more than welcome to be shared and followed on with everyone else. The more the merrier, of course. So with that being said, thank you for everyone's time. You will be getting an email with this webinar sent to you as well, just in case you want to look at it again. And it will be posted on the community as well. So for everyone that joined, thank you so much, and we look forward to seeing you soon.
Great, thank you. Bye now.